The gradient of a curve which passes through the point P27 is given by dy dx is equal to that. We are supposed to find the equation of the curve and then the equation of the normal to the curve at P. So we start with what we're given, dy dx, dy by dx is equal to 15 over the square root of 7x. Leaving out the brackets, they're not important. So we can integrate both sides. When you integrate both sides, you're going to get y is equal to the integral of 15 over the square root of this quantity. And this is equal to the integral of 15 times 7x plus 2 to the power minus half. Minus half because, well, the square root of anything, or taking the square root of a thing, is the same as raising it to the power half. And now we are dividing. And when you divide, the index becomes negative. So that's what we get. How do we integrate this? We are basically trying to find the function whose derivative is what we have here. So we are trying to do the reverse of differentiation. And so we can think in terms of the chain rule. If we have some quantity, so let's say you had x and x to the power 3, and you wanted to integrate, then you just use the rules of integrating polynomials. You increase the power of x by 1 and you divide by the new power. So that's 1. But then we also have something like this, or let me use the exact one that we have. We have 7x. So we have 7x plus 2. So if you had this, for instance, and you wanted to differentiate, what would you do? You would treat it like this. You first treat what is in the brackets as one variable, if you will, and then you integrate like this, and then you differentiate like this, and then you multiply by the derivative of what's inside the brackets. So you multiply everything by 7. That means that if you now you simplify this to get 14 times 7x plus 2. So now if you wanted to integrate this, what would you do? Well, you can increase the power of x by 1, or the power of what's in the brackets by 1. When you do that, you get 7x plus 2 to the power 2. Then you divide by the new power. We have the 14 here. Divide by the new power, that is 2. So let's do that and see what we get. When you do that, you get 7 times 7x plus 2 all squared. So that's not quite this one. This is what we are supposed to get, but we ended up getting this one. What that means is we have this extra 7 here. Where did it come from? It came from what we get when we differentiate this, what's inside. It means that we have to divide all that we're doing by 7 to get rid of it. So that's the idea we're going to use here. So here we can say, well, increase the power of x by 1, or increase the power of what's in the brackets by 1. So 7x plus 2. Instead of to the power minus half, we add a 1 to the minus half. So 1 minus half is going to become a half. And then we divide by the new power, which is half. We already have our 15 here. And now we are saying that in addition to doing all of this, we have to divide by 7, like we had to do here. So now we have to divide this by 7. All right. So we simplify. What do we get when we simplify? This is going to be equal to 30 over 7 times 7x plus 2 to the power half. And this is equal to, I should I should add plus c here. All right, so let's do that. Plus c, the constant of integration. So this is going to be 30 over 7. So 7x plus 2 under the square root, and then plus c. All right, so this is what we have for the equation of the curve. The plus c is something we would like to resolve, something we would like to get rid of. But we are told that this curve passes through the point 2, 7. So we can use that fact to find our c. Now, if y is equal to this, then substituting, so our y is going to be 7 and our x is going to be 2. So we can write 7 is equal to 30 over 7. Square root of 7 times x is 2, so we put it here, plus 2 plus c. So we can multiply both sides by 7. 49 is equal to 30 times. Now, we can begin simplifying what is under the square root. We have 7 times 2, it's 14, plus 2, 16. And then we have plus 7c. And then we simplify further. 49 equals, the square root of 16 is 4, so this is 120 plus 7c. So that gives us 7c is equal to minus 71. That means that our c is equal to minus 71 over 7. So we come and substitute that into this. When we do that, we now get our y is equal to 30 over 7 times the square root of 7x plus 2, and our c is minus 71 over 7. Let me put a red box around that so that it's clear what our answer is. So having found that that's the equation of the curve, we are now being asked to find the normal to the curve at P. The normal to the curve. So what is the normal? The normal is that line that is perpendicular to the tangent. Now, if we can find the gradient of the tangent at P, then we can use that. So the gradient of the tangent at P is the same as the gradient or the derivative at that point. So the derivative of a curve at a point is the gradient of the tangent at that point. So gradient, let me write that. The gradient at this point, 2, 7. What is that gradient? Because we have dy dx as this, we are just going to substitute the value of x into that. That's going to give us the gradient. So we have 15 over the square root of 7x. So 7x is 7 times 2 plus 2. So this is going to give us 15 over the square root of 7 times 2 is 14 plus 2 is this. This is equal to 15 over 4. So that's the gradient of the tangent at P. So what is going to be the gradient of the normal at P? The normal, like we said, is perpendicular to the tangent. And when a line is perpendicular to another line, the relationships between their gradients is that one is the negative reciprocal of the other. So the negative reciprocal. So now that we have the gradient of the tangent as 15 over 4, the gradient of the normal is going to be negative 4 over 15. That's what the negative reciprocal of 15 over 4 is. So if we have the gradient of the normal, now can we find the equation of the normal? We are being asked to find the normal. So what's the equation of the normal? Well, we have the gradient of the normal and we have a point on the normal. So that's what we're going to use. The gradient of the normal is this. So using the point slope form of a line, we have y minus 7 is equal to minus 4 over 15 times x minus 2. This is the gradient of the normal that we can decide to simplify further. Multiply both sides by 15. We have 15 times y minus 105 is equal to minus 4 into x minus 2. 15y minus 105 is equal to minus 4x plus 8. All right, so 15y plus 4x. We can bring the minus 8 also to the other side. So we have minus 113 is equal to 0. So this is going to be the equation of the normal.